Assalamualaikum. Okay, today we continue with our lesson. Last time we learned about potential difference. What is potential difference or voltage? Okay, it's defined as work done or energy needed to move 1 coulomb of charge from one point to another point in an electric field. And we have the formula V equals E over Q. Now we continue to do some exercises regarding the formula. For example, question 2. If a charge of 5 coulomb flows through a wire and the amount of electrical energy converted into heat is 2.5 joule, calculate the potential difference across the ends of the wire. So look at the information given. So 5 coulomb refer to Q. Q equals to 5 coulomb. And then 255 joule equals to energy. So calculate V. So we have the formula E equals to QV. So V equals to E over Q. And 2.5 divided by 5 coulomb. And we get the answer 0.5 joule per coulomb or 0.5 volt. Okay. Example 3. A light bulb is switched on for a period of time. In that period of time, 5 coulomb of charge pass through it and 25 joules of electrical energy is converted to light and heat energy. What is the potential difference across the bulb? So what are the information given? Okay, 5 coulomb, Q equals to 5 coulomb. 25 joule equals to E. Again, we are going to calculate potential difference V. So V equals to E over Q. Equals to 25 divided by 5 equivalent to 5 joule per coulomb equals to 5 volt. Easy, right? Okay. Question 4. When the potential difference across a bulb is 20 volt, the current flow is 3 amp. How much work done to transfer electrical energy to light and heat energy in 50 seconds? Wow, this time give you T equals to 50 seconds. You are given I equals to 3 ampere and V equals to 20. So our task is to find energy, E. So we have the formula E equals to QV. But we do not know Q, but we know that Q equals to IT. So we have to use the formula Q equals to IT. And we get the formula E equals to QV equals to VIT, where IT equivalent to Q. So we insert all the value. 20 is the voltage, 3 is the current, and 50 seconds refer to the time. So we have 3,000 joule. Alright. Okay, now we move on. So we are going to do one experiment in order to study relationship between current and potential difference. So now we have two quantity physics, current and potential difference. Okay, the first thing we have to know is to set up a circuit, and we have to draw the symbol for the electrical device. Okay, so here are the lists of the circuit of the device that we have to know. Okay, the first one, ammeter, the symbol is like that. Voltmeter, connecting wire, resistor, cells or battery, switch, constant wire, bulb, and rheostat. Okay, so that are the symbols for the electrical device in the circuit. Next step is we have to know how to measure current. So measuring current. So the diagram show arrangement apparatus to measure current. So we have the bulb, we have the switch, ammeter, and bulb. Notice that they are arranged in series. Okay, from the positive goes to the ammeter positive, negative go to the bulb, and goes to the negative terminal. Okay, how to draw? So remember the symbol we learned just now. So this is the symbol. So the battery, we have the switch, we have ammeter, we have a bulb, and go back to the battery. Remember the battery is only one, so we draw one battery here. So name the device used to measure electrical current. So ammeter. Okay. What is the SI unit for current? And write the symbol for the unit of current. Okay, SI unit for current is ampere and the symbol is A. Remember, the unit, the symbol for current is I. Remember. How is an ammeter connected in electrical circuit? So they are connected in series. The positive terminal of ammeter is connected to which terminal of dry cell? Of the dry cell. So it should be positive. So positive to positive. So what will happen if the positive terminal of the ammeter is connected to the negative terminal of the dry cell? So the reading will below than 0. The pointer will show below than 0. So when that happens, quickly you have to change the terminals. Okay, now measurement of potential difference. Okay, so we have this time we have one battery, switch, state ammeter, bulb, same like just now, last time. But this time we have the voltmeter connected in parallel with the bulb. So draw the circuit diagram. So this will be the circuit diagram. So this the top one is the same as just now that we learned just now. So the positive ammeter goes to the bulb and goes to the negative, and then you take two connecting wire, you connect across the bulb to the potential difference, to the voltmeter. Okay, name the device used to measure potential difference. Voltmeter. What is the SI unit for potential difference? Write the symbol for the unit of potential difference. So volt, and the unit symbol is V. How is a voltmeter connected in an electrical circuit? So they must be connected in parallel. Ammeter must be in series, voltmeter must be in parallel. The positive terminal of a voltmeter is connected to which terminal of the dry cell? It should be positive. So what happens if the positive terminal of the voltmeter is connected to the negative terminal of the dry cell? So the reading will will below 0. Alright, so we have the first experiment for today. So we want to study relationship between current and potential difference. So look at these two diagrams. So diagram A shows you one battery connected to the bulb and to the voltmeter, to ammeter. Diagram on the right, B, we have two batteries connected to the same bulb. So what are the difference that you can see from both diagrams? So the first one, look at the brightness of the bulb. So here is dimmer, here is brighter. Another one is the value of the ammeter reading. So ammeter reading on the diagram B is bigger than on diagram A. Okay. So the question is, why do the ammeter show different readings? Why do the bulbs lights up with different intensity? So we are going to have one inference. So current influence the brightness of the bulb. Okay, so current influence the brightness of the bulb. And the hypothesis, current influence the potential difference. Remember, brightness, we cannot measure the brightness of the bulb. So brightness we change to equivalent to a current or potential difference. Okay, so here is the apparatus. Okay, so you have a battery. You really must make sure that all the connection are tight so that the ammeter, so that the current will flow. Okay, from the battery goes to the rheostat. Okay, at the bottom here goes to the, at the top goes to the connecting wire or the constant wire. So we have fixed the length of the constant wire, and then go to the switch, go to ammeter, and back to the negative terminal of the battery. And we take a voltmeter parallel to the across the constant wire. So this is the circuit diagram. So 0.5 volt, 3 battery, we have rheostat, constant wire, and the switch, and the voltmeter parallel with the across the constant wire. So how we do the experiment? It's very easy. First you arrange the diagram, the circuit, and then you adjust the rheostat until current equals 0.2 ampere. And then you record the reading of the ammeter and voltmeter. So write down in the diagram. So you calculate the value, the ratio of V over I. And then you repeat the experiment with 0.3 ampere, 0.4 ampere, 0.5 ampere and 0.6 ampere. At least you have 4 repeated values with altogether 5 values. Okay, we have discussed just now the hypothesis: the larger the current, the larger the potential difference. And what is the manipulated variable? So easier for us to manipulate the current by using rheostat. So current will become the manipulated variable MV. The responding variable will be either potential difference or also resistance. And the constant variable is the length of the constant wire. Okay, length of the constant wire, length of the conductor. Okay, so plot the table of the data. Okay, and then you plot the graph. Okay, this is what we get. Okay, so this is the data and we plot the graph and we get a straight line graph. Okay, so this is a straight line graph. So based on the graph, state the relationship between V and I. So this is directly proportional. So V is directly proportional to I. Okay. State one precaution. Open the switch if not taking any reading. Of course, another one is make sure the position of the eyes must be perpendicular to the scale of the ammeter or the voltmeter. What is the function of the rheostat in the circuit? Again, we want to manipulate the current, so we have to control the current flows by using rheostat. Okay, so what is our conclusion? So we have what we call Ohm's law. So we have a statement: the current flowing through an ohmic conductor is directly proportional to the potential difference across its end, provided that its temperature and the other physical condition remain constant. Or in other words, current directly proportional to potential difference if other physical remain kept constant. Okay, so this is Ohm's law. OHM across the PS. Ohm's law. From the graph, we can calculate the gradient of the graph. So how we show? We have to show the method to calculate gradient. So we draw a straight line here. Okay, so we have the value of y 1 minus 0 divided by 0.5 minus 0. Remember 1.0 volt and divide by 0.5 ampere. So the answer is 2.0 volt ampere negative 1. So what is the physical quantity represented by the gradient of the graph? So this is what we call resistance or rintangan, R. So define resistance. So resistance is charge and counter resistance when they flow through a conductor. So we have the first, the next definition: potential difference or voltage over current. Okay, potential difference over current. What is the unit for resistance? So V A minus 1 equals to ohm. The symbol is ohm or omega. Write an Ohm's law equation. So we have the formula just now. V over I equals to R. So we have R equals to V over I. And we have V equals to IR. So this is the equation for Ohm's law. Okay. So where V equals to potential difference, I equals to current, and R equals to resistance. Okay, we have a triangle, magic triangle, in order for us to use the formula. Okay, next is we have the word what we call an ohmic conductor. Ohmic conductor which obeys Ohm's law. As current I increase, the ratio V over I is constant, and we get a straight line here. Okay. Another one is non-ohmic conductor that does not obey Ohm's law. So the graph will be not a straight line, will be a curved line. Okay. So for example, we have a light bulb. So light bulb will be a non-ohmic conductor. Ohmic conductor should be like constant wire, copper wire, and so on. Okay. Alright, quiz. Okay. When the voltage across the piece of resistor wire is changed, the current flowing through the wire also change. The temperature of the wire is kept constant. Which graph shows the correct relationship between the voltage and current? So it should be a straight line through origin. So the answer must be A. Quiz number 2. A student wants to find the resistance of resistor of resistor R using a voltmeter and ammeter. Which circuit should we use? Okay, so we have ammeter and voltmeter. This is wrong. Yes, B should be the correct answer. Ammeter must be in series, voltmeter must be in parallel. Okay, so B is the answer. Alright, another question. Which pair of relay is obtained when a suitable power supply is connected between X and Y? So this X and Y, 24 ohm. So we want to have which one has the correct ratio, I think. So V over I, right? So 12 divided by, so we should get 24. So 12 divided by 0.5, I think the answer should be C. 12 divided 0.5, we get 24 ohm. Okay. Okay, next question. Okay, which of the following is true? Okay, we have P and Q, resistance P and resistance Q. Okay, remember VI give you the resistance, so P has a larger gradient, so it should be have larger resistance. So the resistance of P is greater than resistance of Q. The answer should be C. Alright, correct. Alright, next question. Which one is the correct ohmic conductor? It must be straight line. So A is the answer. Alright, that's it for today. So we stop here. So we see you next lesson. Thank you.